Welcome back, my friends. I'm Kylan Hunt, VP of Business Development at Grow Guru, and we have with us again today Dr. David Sloan. And I've asked Dr. Sloan to come in and talk with us a little bit about what does it mean, or how can we tell once we put a soil sensor in the ground, how can we tell when we finally have the soil profile full of water and we're ready to start growing a crop? What are some of the signatures that we look for, David?
Well, I can tell you what you can't do, and that is you can't just stick a probe in and know how wet it is. You can have a calibration, you can look at the numbers, but the numbers don't really mean much. What you got to do is watch the soil respond to moisture. And so can it catch the moisture, or is moisture draining through? Is water draining through to the next level? So I've got some data here that I'd like to go through. So what we can see, if I just have a look over here, is it's a probe that's got 6 sensors. It's actually a shallow probe, a 24-inch probe. First sensor is at 2 inches, and then we get down to 22 inches. So each of these colored lines are 4 inches apart. And we can actually see that when water comes on, or this very first time water hits, the blue line moves, but the green line doesn't. And then we get to a point where the blue line at 2 inches, it's got kind of a sharp peak. And then the layer below that has come up. So we know water has made it to 6 inches, but we're not quite sure if it's fully wet. So, but there is a difference in signature here. This has got quite a sharp peak to it, whereas we get down to the next layer and it's got a shoulder to it. And then we go deeper and we can actually see that water has moved to the lower levels at 10 inches and 14 inches. By the way, the gray line has hardly moved at all. So that water is kind of like a wave washing up a beach. It's kind of petered out by the time it got to the 14-inch level. But it's really only at the top where we see a bit of a peak. All the rest of them have got shoulders that get less and less. And so then we had a very minor shower, and we get to an irrigation. And what's different here is that the blue and the green have got that real sharp peak to them. And actually what's happening is we've now coated all the soil particles, and so water can't stick. There's nowhere else for water to stick, and so gravity's taking over and it's running to the next level. That next level here is down at the red line, and so that red line has got that kind of shoulder to it. And now water is moving through because it's moving through the wet soil. It's gone to the orange line down here at 14 inches. It's now moving through to the gray line at 18 inches. So you can see there's a bit of a delay as water moves through. Didn't make it to 22 inches, but also we've got that sequence of catching moisture and then holding it versus still wetting up and still wetting up. We get to the next irrigation, and what we can see over here is a sharp peak, and the blue line, the green line, and the red line. So we've really found the point that the soil can't get any wetter. And incidentally, we're starting to get good correlation between one irrigation and the next. So we can be pretty confident that we've actually found the full point. And notice that it's not actually at the highest point in the data. It's actually after drainage has ceased. You'll get a bit of an inflection point here. And then the layers below that, we're almost wet at the orange line at 14 inches. Because it's come up and it's leveled off pretty quickly. And you can see now water is moving all the way through to the 22-inch layer. So if we kept going with more irrigation or more water applied, then we'll start to see that happen at the lower levels again, the orange line, the gray line. And it's that signature where you're observing the fact that the soil can't hold the water is the key. And so it's very much in the signatures, not in the numbers. And I can tell how wet this is. There's not even a scale on this graph, and yet I can see through that relative measurement. And that's the value of continuous monitoring. And by the way, if I took this probe out and put it back in, all this resets. So I've got to learn it all again. And that's a pretty critical thing as well. Good reason to find this out and leave it there, because you'll get more and more repetition and you'll be able to be very confident in the full point.
Oh, okay. I've got a couple of different questions. We'll go back to the graph here in a second, but what do you mean by that? If you take that out and you put it right back in, you're going to have to relearn that. Can you share with me what you mean there?
Yeah, so these sensors, they're very, very precise, but they're also very sensitive. And so how the soil sets up around the outside of them really matters. And so that installation is critical. It's why we try not to have any air gaps around there. It's because that air-water mix is what we're really measuring. So, if you take that out and you put it back in, you're going to get just subtle changes. And certainly, if you reinstall it the next year, then none of this carries over. But if I took that probe out and put it right back in the very same hole, I'd have to relearn everything all over again.
You'd have to reset it, start over,
yeah,
right?
Every time.
Right.
So,
interesting.
And then you think about that if it's the start of a cropping season, and my crop's already at my corn might be at V4, then it's using water. So I might never find the full point. It might be that it's already taken out some moisture and we don't see that wetting all the way through. So you may never know how wet the full point is, which is pretty critical because that's what you drive everything else from.
Absolutely. And that I noticed that down in south central Kansas several years ago. We put probes in and it was dry, and we could feel it was dry in our hands when we put it in, later in the season, but we had no good way of knowing. I mean, we put probes in at V4. We never did catch up. We had no idea what our full point actually really was.
Yeah. And that's you've got no chance because that is the baseline. The baseline is that fundamental signature where you see the soil can't hold any more water, and it almost never gets saturated again once the crop's in the ground. And so, especially if you're in a drier environment, if you're fully irrigated, sure, if you're somewhere where it's supplementary irrigated, you get rainfall, you might see that. But there's plenty of situations where I've seen where you just never know.
Can we run back to that data right quick? I've got one more question for you, David.
Yeah, sure.
So in this data set on your top sensor, your little 2-inch sensor, I think you said it was at 2 inches, right in the middle of your graph, you've got like a little, just a little blip up and it comes right back down right in the middle. Yep. I'm guessing that was a little rain event or something of that nature.
Yeah, that would be a really small shower. I can't recall exactly, but yes, that's just hardly even wetting up the topsoil.
Yeah. What I noticed there, though, and this is where I think the other element that makes sensors so critical is it never even had any kind of effect on the 6-inch level. Mm-hmm. And it looks to me like that may have held on and actually, it rained for potentially a few hours there, but it was really slow, a light amount. And yet it didn't even make it to 6 inches. Is that what we're seeing?
Yeah, and this is actually sandy potato ground. And so a lot of people just expect they say, hey, I've got sandy ground, the water's going to wash in, or wash through really quickly. You'd be surprised how much water it actually can take to wet through. And so it's only by watching and learning that you can see these signatures. They're very clear. And, if I see something that like this red line here that comes up, but it's got a pretty, it's almost a 90-degree shoulder on it. What that means is it's caught all the moisture that got to that level. None of it hasn't gone up and come back. And so it hasn't washed through, not like it has when it got to the last irrigation event here, where it really does have a sharp peak and a bit of a shoulder. And as we get some more events, we can be really sure. We'll see that it lines up at the same level. It's the same soil, so it gives us confidence. So that the longer you've got these data sets, you can come into the season knowing. So if I put the probe out in the winter time or the springtime, and I get that really wet period, it might be snow melt, it's too wet to even plant, and then you got to let it dry out. Well, what you've done is you've actually captured that full point. So you go into the season already ahead.
Yeah. Oh, that makes a lot of sense. Well, I know there's going to be other data signatures that you want to share with us, correct?
Yeah, absolutely. There's a whole suite of signatures, so happy to run through them.
Perfect. Well, I think this was huge. I was thinking back to the example that you did in that water pot, showing saturated soil and dry soil, and you can kind of correlate it there now. These graphs make a lot more sense now that we've watched those videos. So I think that was huge.
Yeah, and
So,
we've got some artificial intelligence built into the software that helps pick what these signatures are. They're very clear, and so we can see how deep the water has penetrated, how quickly, and so that also makes it easier to read for people trying to cover a lot of sites very quickly. We can do some of that heavy lifting using the computing or the power of computers.
yeah, absolutely. All right, my friend. Well, let's jump on another video here in the very near future, and let's talk about some other data signatures. That's pretty intriguing. I think that's more
Okay,
valuable than anything the numbers can bring to us. So,
absolutely. Thanks,
all
Colin.
right, all right. Thanks a lot, David. Greatly appreciate you, my friend. And there we have it, another lesson from David Sloan. Always great to hear from him. Always great to see how to use this data to really drive dollars to make money in the root zone. And guys, this is really exciting when you see. In fact, if you join in with us through the next several videos that we're going to be doing, David's going to share multiple things about these data signatures. And what does he mean by data signatures? It's how the plant and how the soil responds to any type of wetting event. If the plant is drawing out water, there's a signature for that. You're going to see things in a different light. As the plant is growing from the growing season, you're going to see it. When we have water come up from the bottom, you can see it. Water through drip irrigation, you can see it. There are things there that we're going to be learning over the next several weeks. So again, click the subscribe button and push the notification tab so you get all of our notifications. We've got a lot of education that we're going to bring to you over the next several weeks. You're not going to want to miss this. All right, my friends, God bless. Make it awesome. We'll see you here next time.